All right, here we go. We're going to be working on lesson 3.6, which is transformations, and we're going to do transformations of linear functions. So first thing we're going to start with is we need to write a coordinate plane. All right, so here it is, my y and x axes, and we're going to take the function the f of x, remember, which is just the same thing as y, equal to 2x plus 1, okay? So let's graph that function, okay? Starting, right, we're going to say that this is going to be the y-intercept of 1, right? And then our slope is 2, which means we're going to go up 2 and right 1, rise over run. I'm going to go ahead and I'm just going to connect these dots, okay? So we're going to do, in addition to this, is we're going to graph here, where we're going to take a function, which is the g of x, which the g of x is equal to the f of x minus 3. So all we do in this event, right, is that this is the same function we have, but it's going to be translated down 3 units, okay? So in other words, we have our new function here in blue, the g of x. So here in black, this is the picture of the f of x. That's the graph for the f of x. Now we're going to show the graph of the g of x, which means we're going to go down 3, and we're going to perform the same exact thing. So we're going to go down 1, 2, 3, right? Because if we're going down on the y-axis 3 spaces from where the f of x started, right? And that's it. Everything else is going to be exactly the same, okay? So my slope is going to be the same, and these lines will wind up being parallel, okay? So this is my graph of the g of x. Okay? Same deal. We're now going to graph something else. I'm going to use a different color here. Let's see here, just to illustrate for you guys. I try to stay away from using red, but we're going to actually use red here. We're going to have the h of x that's in red. Ooh, that is quite the tip. Let's go ahead and write this guy in. Oh, let's use this maroon color. That's nice. Okay. It's actually purple. Nice school spirit. So we're going to have the h of x. Okay. The h of x in this case is going to be the f of x, but in the parentheses, it's going to be the f of x minus 3. Now, the transformation is a horizontal transformation, okay? It's going to translate not to the left. This is where we're going to get ironic. It's actually going to translate to the right, okay? We're going to go right by 3 units. 1, 2, 3. Okay? And when we create this graph, again, it's up 2 over 1. This is the graph of the h of x. So some conclusions. This is what's called a translation. And this is going to go down 3. Same thing for this transformation. This is a translation where we're going to slide the graph. Instead of, because it says negative, it's actually going to go right 3. And I remember being a math student and trying to figure out, wait, that doesn't make sense to me. Why, when it goes vertically, it makes sense, plus and minus, plus is up, net minus is down, but it didn't really make much sense to me horizontally why it would go right with negative and left with positive. And I want you to think about this. If it's going to be the f of x, it's going to be what is applied to the x, right? And that's still going to be equal to an output. So think about how the inverse operation works. Right? It means that we're going to wind up adding 3. in order to solve for that x and getting it by itself, right? And when we do that to my output, right, it winds up being a positive 3, and that's why that guy gets changed in that fashion. So don't know how to really explain it better than that, but in other words, it's going to effectively work like this. Positive means up, negative means down, positive means left, negative means right, when we're working with horizontal and vertical transformations. Okay? Next, it's going to be referred to as the reflection. Okay? And this one, it's hard to see because they're going to look pretty similar when we actually do these things. Okay? So we're going to do reflections about the x and so up here we did translations. Okay, that's one type of transformation. Next we're going to do reflections. So let's go ahead and take another graph here. Okay, we're going to take a function. So up ahead we used f of x is 2x plus 1. Here we're going to say the f of x is going to be equal to 3x plus 2. So it's a positive slope. Okay, so let's go ahead and graph it in our coordinate plane. Okay, so let's go ahead and graph our f of x up to, it's my y-intercept, and then my slope up 1, 2, 3, right, 1. Okay. Now, we are going to graph the g of x in blue here. And our g of x is going to be equal to the negative f of x. Okay? What we're going to do here is we're going to reflect this over the x-axis. Okay? All right, so we're going to do that and reflect over the x-axis, okay? Same deal. So if we had inputs and outputs, all of our inputs are now going to be, are going to stay the same, but our outputs are going to wind up being have their sign flipped. So in other words, if I were to input back on the f of x, okay, and I prefer when I do it like this, x, and then I'm going to say the f of x. Okay. -1, 0, and 1. When I put a -1 in, right, that's going to be a -3 plus 2, which is going to be a -1. If I put in 0, it's going to be 2, right? And again, I'm inputting it back to this equation, right? If I put in a 1, it's going to be 5. Okay? So, think about this. If it's going to be the negative f of x, the g of x, okay, so the negative f of x, which is this g of x, all I'm going to do is I'm going to switch these signs. This is going to be 1, this is going to be a -2, and this is going to be a -5. So in other words, x is -1, okay? X is -1. This guy is going to be a +1. 0, it's going to be a -2. 1 is going to be a -5. and that is the g of x. Again, the black is the f of x. So what did we notice? We made our y-intercept negative, and we also effectively then just utilize a negative slope, okay? Next, let's do another transformation, but this time, and I'm going to make another axis here just to not muddy the waters, and we can actually see a little bit of the difference. Where y and I have x, again I have up to, and then 1, 2, 3. This is my f of x. Same equation, okay? But this time, again, in purple. This is going to be my h of x, which my reflection is going to be the f of the negative x. Okay. This guy is going to be a reflection over the y-axis. And here's how it works. Again, if I had my x, and let's use -1, 0, and 1, right? We already have my f of x. We already did that, right? That was -1, 2, and 5. But if I have my f of negative x, it's going to be a little bit different here. Okay? What's going to change is that my x is going to change. Okay? So here, the f of negative x, what I need to account for is not the f of x, like I did before. I need to account for what negative x is. So I'm just going to switch my values. 1, 0, -1. Okay? And put those guys in. So we're going to take 1, and then we're going to evaluate the f of x, and it's going to be 5. Zero, it's going to be 2. -1, and it's going to be -1. Okay? Let's see what that looks like. -1. And this is my f of negative x. Sorry. Up 5. 0, 2. And then I have -1, 1, and then I have a -1. Here's what my line looks like. And this, of course, is my h of x. Next two, we're going to do stretches and shrinks. Okay, so we're going to again have a function. Y and x axes, and my f of x is going to be equal to negative x plus 2. Okay, so up 2, down 1 over 1, right? It's a slope of negative 1. Now we're going to graph the following, which is going to be the g of x, and our g of x is going to be the f of 1/2 x. Okay, this guy is what's going to be known as a stretch by a factor of 1 divided by 1/2, which is equal to 2. Okay, this is how this guy works. Same graph. It's going to be the same exact y-intercept. Okay. But where my slope was negative half, right? This guy is going to be a negative. My slope was negative 1. I'm going to multiply that slope by 2. So it's going to be down 2 before I go over 1. We're going to connect our dots. Because the slope of f of x equals negative 1, and I multiply by 2. Guys, I did that wrong. I did that backwards. I'm sorry. It should be this way. Should be 1, 1, 2. It should be right here. My apologies when we do that stretch. Okay. Sorry, it's a horizontal stretch, not the other way around. Because it's inside, it works like this the other way, right? We're going to do a vertical stretch. Okay, it's going to work like this. So there's my y and my x. Same guy here, up 2, down 1 over 1. Okay. That's my f of x. Right? This is the f of x. This is the f of x. Over here in blue, this was the g of x. And then in purple, okay, we are going to do the h of x. The h of x is going to be 2 times the f of x. This is what I was doing before, right? And this guy is going to go down 2 and over 1 to get us this stretch. Okay? And this is going to be a vertical stretch. Again, describing it. Stretch by a factor of 2. And again, this guy's a vertical stretch. So you have to memorize if it's done to the inside horizontal, right, and to the outside vertical. All right. How do we do shrinks versus stretches? Okay, so we've done stretches. Now we're going to work on shrinking the graph. Okay, and it's going to just work where, notice that I did the fraction on the inside. So here we're going to say the f of x. Okay, in this case it's going to be equal to 2x minus 2. So let's go ahead and graph this guy. Okay, so my coordinate plane, I have y and x. It's going to be down 2, up 2 over 1, right? La la la, connect the dots. It's my f of x. And now I'm going to work with a g of x. And remember what I did before. I did the f of 1/2. This time let's do the f of 2x. It's going to be 2 times inside that thing. So it's actually going to be a shrink by a factor of 1/2 in this case, okay? Inside. So this is the way this guy works. The g of x, same exact y-intercept, -2, okay? Or my slope was 2, now I'm actually going to entertain effectively a slope of 4. So this guy winds up being much more stilted. This guy is my g of x. Okay? The reason I double it is because of the 2. And my slope here was the 2. Okay? So 2 times 2 being 4, so up 4 and over 1 this time. And this guy is the shrink, vertical. I'm sorry, horizontal shrink. Let's take a vertical shrink. Let's see what it looks like. Y and x. Okay. Again, my f of x down 2, up 2 over 1. Connect my dots. There we go. There's the f of x. And a new deal here. Here, my h of x. Now think about what we're going to do to, before we multiplied by 2. Here we're actually going to multiply by 1/2 of the entire function. So half the function. Okay? Well, what is that going to wind up doing? It winds up being a vertical shrink. So this guy is a little bit tougher to wind up dealing with, okay? Because we're going to actually have to deal with this x-intercept here, which we're still going to maintain here, okay? What we wind up taking a look at is the following. If we did one of my tables again, so x, right? So we have the x and we have the f of x. So x, if we're going to say -1, 0, and 1, right? -1, we put that in. And that's going to be -4. 0 is going to be -2, right? I'm inputting back up here, right? Into that. 1 is going to be 2. 2 times -2, which is going to be 0. But what I want to do here is I want to do the 1/2 of the f of x. So just take half of all of those values. So this guy's going to be a -2, this guy is going to be a -1, and this guy's going to be a 0, right? So -1 is going to be -2. So -1, -2, it's right here. 0, it's going to go through -1, and then 1 is going to go through 0. So it winds up being going through this way right here, and that's my h of x. So it's a little tricky. Again, this right here is going to be a vertical shrink. Okay, we're going to shrink this. Of 1/2 still. So it's a bit to kind of decipher here. I think the vertical shrinks and stretches, and I don't get too occupied with calling it a shrink or calling it a stretch, because again, it just depends on what we're going to do to that value inside or outside. But we're going to wind up, we need to make sure that we're applying this appropriately, okay? So that's that. So if you guys have any questions, you guys can feel free to reach out to me. Go ahead and give your assignment on Canvas in attempts. Good luck.